So this is CNET 121 Forensics, and we're here. We're going to do Mod 11. There's only one more class after this, and I won't have any lecture. I'll just answer questions and help people that are still working on projects, and then the final exam is available. You should know what grade you're getting. It's just based on your total number of points. You can see it in Canvas, and if you look in the announcements section, you can see a chart that shows you how many points it takes to get an A and a B and a C and so on. So you should be able to see what you're getting and figure out how much more work you have to do to get whatever grade you want. Oh, let's take a look at this lecture, which is mostly about Apple and then a little bit about IoT at the end. So the Apple Mac is, of course, important. Many people are using them, even in companies, although in my opinion Apple mostly targets the home market, but there are people using them at work, and they have a lot of different gadgets: the iPod, the Apple Watch, their own Apple TV, the Airport Express router, and so on. All right, so the Macintosh file system is an old file system. In '84, it went upgraded to HFS, and it eventually went up to HFS Plus, and then the current one is called APFS, the latest version of what they use. It is really quite sophisticated. The catalog file is stored as a B tree, which is a smart structure to efficiently allow you to search through the file system. And so it's got a volume header and an alternative volume header, and a catalog file with the metadata, and allocation blocks are the sectors, basically the units of disks that are allocated to a file. So the Apple file system has a ridiculous number of addressable blocks, 2 to the 64, which is a huge number, has timestamps in nanoseconds, and when data is duplicated, the data content is not replicated, only the metadata is duplicated. So this is a way to save disk space. If you make a copy of a file, it doesn't really make 2 copies of the file until you modify one of them. And this is something that Docker containers have really taken to the limit with their layer FS, which is what's used to make the Docker containers so much more efficient than virtual machines. They also do not make a new copy of a file unless you change it. So if you have a Linux host and you put a Linux Docker container on it, it is essentially of size 0 at first, and it only grows to a small size when you use it by only recording the changes you made to the host operating system, which is why Docker containers are much smaller, faster, and cheaper, and more efficient than virtual machines, but less secure because they actually do share files with the host. All right, so iOS has a lot of layers of encryption. When you enter your password, it loads a key from the user key bag and unwraps it with a key derived from the password you put in. There's a backup key bag and an escrow key bag, and so on. It has many layers of encryption. And it has a T2 security chip in it, and this is the equivalent of the Microsoft Platform's Trusted Platform module. And on an iPhone, it's called the Secure Enclave. In all cases, this is a cryptographic coprocessor. In addition to the main processor, which does normal calculations, the cryptographic coprocessor can store keys and perform cryptographic operations using the keys, and it is not anywhere in the memory space mapped to the main processor, which means that no malware on your machine could possibly steal those keys. The only way to steal those keys would be to physically compromise the chip. There's been attacks that dissolve it with acid and such, to reach in with a microscopic probe to detect the electric signals on the pins inside the chip. So that's very good. That's what the T2 security chip does. It's a place to conceal cryptographic keys where it can't be stolen, or it's much more difficult to steal. All right, so it's got space sharing, so multiple files can share the same underlying free space. So that sounds like another way to save space on the disk. I'm not quite sure how that works, and it seems like it would present a bit of a challenge for a forensic analyst trying to recover deleted files. But anyway, that's what it does. All right, and so to do a forensic examination, you can search on your Mac with Spotlight, just in a magnifying glass in the top right corner. That will search through looking for things. And it caches data here, so you can see what people have been searching for, I think is what you find there. If you move things to the trash and then empty the trash, they cannot be recovered. Now, the statement made here sounds the same as Windows on a hard drive. The OS no longer maintains a link to reference that, which means you've lost the metadata. You've lost the file name, owner, and timestamp information, but on a magnetic hard drive, you will not have really lost the contents of the file. You'll be able to recover it. Now, however, in practice, most modern Macs use SSDs. In fact, I think a lot of modern PCs use SSDs, and SSDs typically do not retain deleted data to any significant extent. There's a garbage collection process running in the background, and most of the time that erases within a few seconds. It clears any sectors that are no longer active. So deleted files, in fact, cannot be recovered easily. Usually can't be recovered at all. All right, anyway, it has journaling. All modern operating systems have journaling, so they keep track of everything they're doing, so that if they crash or the power goes out, they can recover and pick up where they left off, instead of being halfway through a process and forgetting what they were doing. A DMG image is an exact copy of a file or volume, like a DD image in Linux, just an exact copy. That's why you typically install things from a DMG. You can mount it like a disk. A sparse image is a virtual file that will grow in size as more files are added, and a sparse bundle is like a sparse image. The equivalent of the registry in Windows that has all these configuration settings for the operating system and applications is in plist files in the Mac. They're not just in one place, the registry. They're just files with the plist extension scattered here all over the place, and so they have all kinds of information. plutil is a tool that will present it in a human-readable form. So here is just showing strings, I think, in plist that are all scrambled. But if you use the plutil tool, you can make them readable. There's a sleep image file that contains the copy of RAM, so that's nice, the equivalent of hibernation. And there's a lot of other security features in Mac. Gatekeeper is the feature that enforces code signing. Code signing is very important, and we were talking about this just a couple of days ago in the instant response class. If you just write code and compile it, it will run, and you can do things with it, but you have no way to know if that file is modified. If you sign the file, you have a cryptographic signature that you get a developer certificate, which is not easy to get one. It took me a while to get mine. And then you can sign code with that. And then when people run the code, before running it, they can verify that the signature matches. And that proves that you know who wrote it, and you know it has not been modified after that person wrote it. So if it's a reputable company you trust, like Apple or Microsoft, then you can be reasonably confident that there's nothing malicious about that. It doesn't have any viruses or anything in it. It doesn't prove, of course, that it's not malicious, but it proves that it was really made by somebody who you know, and you can decide if you trust them. That's what signatures are for, and Gatekeeper is the security feature that enforces signatures. And this will happen on your Mac. If you try to download a file and install it on your Mac, it will typically say you cannot install things from unknown sources. So you have to go into security preferences and lower your security level if you want to install random stuff you download from the internet, and that they warn you that that's dangerous. By default, it will only run things that come like from the Apple Store, things that not only are signed, but that are signed by Apple and approved by Apple. That's the default setting for Macs, and it's the only setting for iPhones, which is why iPhones are pretty much free of malware, unless you jailbreak them to escape that. So FileVault is their encryption tool, which uses AES 128, which is perfectly fine. The NIST-approved encryption scheme, as far as anybody knows, is unbreakable. All right, there's a recovery key that you're supposed to save somewhere. But without the key, you're never getting in the FileVault. The disk utility is the tool you can use, like formatting disks, mounting disks, and so on. You can also use command line utilities, diskutil or hdutil that do the same thing. And the keychain is where you store passwords and other things like keys to connect to wireless networks. They all go in the Apple keychain, and this can be dumped without administrator privileges from command line commands in most cases because you use it. Anyway, that's the logical place to put secrets. And then there's an iCloud keychain, which is very important for an analyst because that's available even if the machine is not available. If someone physically destroys their computer, for example, the iCloud backups will still be there. You can get those by subpoenaing Apple. And if you have an iPhone, which is encrypted, and you can't get in because you don't have the face recognition or the thumbprint or the PIN, then you can still get the iCloud backups by subpoenaing Apple, and that's quite useful. All right, so Safari is the default browser, of course, and it has a browsing history, downloaded files, a cache, and cookies, all the usual stuff that any other browser has. And you can also copy the contents of a disk with target disk mode. You can boot a Mac and turn it into target disk mode, where it just treats it as a storage device to be connected with externally through a USB cable, or I guess a FireWire cable, or now whatever the modern cables are on the Mac. And that's just a handy way to mount it as a volume so you can copy the data off it. Then, of course, the mobile devices, the iPhone and the iPad, those and the Apple Watch. These are all using the mobile version of Mac OS, which is very similar to the Mac OS you have on a desktop computer, called iOS. And so everything in here is encrypted. Everything on an iPhone and an iPad is all encrypted from before. When you start using it, it's all automatically encrypted with a key based on a unique device identifier, hard-coded into the processor. So you can't, if you copy the raw bits doing chip-off forensics, it'll be essentially worthless because you need a cryptographic key that you don't have, and without that it's all just scrambled, which is why you can erase an iPhone and if you just go into settings and restore it to factory default, it deletes the decryption key, and after that all the data is irretrievably gone, and you can totally sell that to somebody else without exposing your personal data. It's very effective. All right. And so it has, as mentioned, layers of encryption, generating different keys. There are various modes that limit what you're allowed to get to. And every app is encrypted with an AES 256 key. So in the mobile device hacking class, we've been talking about that. If you download an app from the Apple Store, you have to decrypt that app before you can analyze it. All right. And so for an iPod, you get these folders, which are very much the same as you'd find them on a Mac. Pictures, contacts, calendars, music, and so on. And those iPads are very much like just big iPhones. And in the iPhone, here's other things you might look at. There's a keyboard cache for autocorrect. Things you've been typing will be, you'll remember what some words you've been typing there. There'll be screenshots created every time you shrink down an application to go to the next application. It saves that screenshot, and it will have one image of what someone saw on the screen. Current and deleted photos and call history and searches and voicemail. This is the main thing people use for data. It shows what people have been doing, and also maps and GPS locations of where the device has been going. And there's a lot of software specific for imaging iPhones and Macs. The most famous ones I've heard of are BlackBag, apparently now acquired by Cellebrite. Cellebrite's really a leader here. There's more Cellebrite devices. And Belgasoft and Magnet Forensics are also big names here. There's just a lot of iPhone forensic software. It's all pretty expensive. It typically does not have any free version. All right. So there's a firmware mode called DFU mode you can use to install firmware on a device. You can use this as part of a jailbreaking process for an iPhone. And recovery setting. So when you boot it up, it gets a boot code from ROM, and it makes sure that the the operating system you're loading is in fact signed by Apple. And this is what you must defeat if you want to jailbreak your phone and install unauthorized apps. In principle, if you use biometrics like face identification or fingerprint identification, you do not have any right to privacy of that information. The United States Constitution gives you a right to remain silent. Or at least it may not be the Constitution, but somewhere in a legal structure. But your face and your finger are not speech. So the cop is allowed to point the phone at your face or put your finger on it, and you are not allowed to resist that. You are allowed to not hand over a password. So the privacy experts say you should use a PIN or a password and not biometrics if you're concerned about that situation being compelled to release this stuff. All right. There is an iPhone backup possible. iCloud is mostly what people want, though, because the whole point of backing up usually is what if you lose your phone or destroy your phone? Then how do you get your data back? You'll wish it was on iCloud, so almost everybody stores their data on iCloud, and therefore it's totally available to Apple, and Apple will hand it over to law enforcement with a subpoena. All right, and photographs, as we mentioned, often have geotagging turned on, so you have not only the photograph, but you have the latitude and longitude and time when that photograph was taken, so that evidence becomes very valuable. All right, and there's a lot of different location services keeping track of where the phone is. One of my students from one of my classes is the one that developed the checkmate exploit. We're a software engineer from Google, took the exploit development class and went and developed this jailbreak, which I was very impressed. It goes far beyond what the class covers. But anyway, this was a jailbreak based on a boot ROM patch that Apple put out, and it means that all the Apple devices for several generations are all vulnerable and cannot be patched. There's a defect in the ROM which can't be fixed with any software update, which makes it possible to jailbreak the iPhones. And so Checkmate was the fundamental flaw, and CheckRain is the full jailbreak based on it. All right, there's something called Apollo you can get that pulls off SQLite databases containing a lot of information about what's been happening on a phone. So when you investigate a Mac, you have to know which version you're looking at, and Macs have a lot of strange ports and strange tools required to open them and such, and a lot of hardware matters like the T2 chipset, Secure Boot, File Vault, disk encryption, and so on. So typically everybody gets those expensive proprietary tools to do Mac examinations. That makes your life a lot easier. You can do some of it with open source tools, but I find that in general the open source Mac examination tools are not really, the free ones are not updated enough to really do a proper analysis of a modern Mac. All right, and then we can talk a little bit about IoT. These are all the other gadgets we have. Thermostats, refrigerators, doorbells. Everything is now connected to the internet. It has a computer, it has memory, and they're often controlled by smartphone apps, and they're often very insecure and often recording information you might want. I'm connected to 5G or 6G internet. You can use Shodan to search for insecure devices, which I don't think is immediately useful for like a normal investigator, because you're just finding random people on the internet. The main purpose of it is for people who want to pull off a prank by just hacking random people, or people who want to convince someone to patch a vulnerability by demonstrating how many vulnerable devices are out there. But anyway, Alexa is of course the voice control for Apple devices. Alexa is Apple? I thought that might have been Amazon. Anyway, there are different ones. Anyway, so if these devices are, yeah, it is Amazon. Okay, that's why you confused me. Oh, this is no longer Apple. Okay, Alexa is Amazon. And supposedly it only listens after you say Alexa, but in fact it listens more. Siri, yes, Siri is the Apple version. And Microsoft is, I think, Cortana. Everybody's got them. And it turns out that all these things are listening a lot more than you think they are, and they're sending that data up to servers, and in principle could be retrieved from Apple with a subpoena. All right, you can install microchips in your body. I know a person that's done this. And even if you don't do that, which not very many people do, you carry your phone around, and that's keeping track of what you do. All these fitness trackers and Apple Watches are keeping track of where you are and what you do, and therefore have useful information. In fact, this just happened in China. It was one of the news articles we skipped. In China, there were a bunch of people that protested the COVID lockdowns over the last few weeks, and a bunch of them would wear a mask and go to the protest and go home and feel like they got away with it. And a few days later, they'll get arrested because the Chinese government was monitoring your phone's GPS. So they know where you were and that you were at the protest. So the same thing happens here, of course, is why that phone location data is highly valued by law enforcement. All right. And so there's cameras that like desktop or whatever the desktop of a car is. The dashboard. There's dashboard cameras to record what happens in there in your driving, which can be evidence for vehicle crimes, and Another thing that is hugely contentious in America is smart holsters. There's people, now the ones that just turn on the body camera and the firearm coming out is fine. Another thing that there's a huge argument about in America is a smart gun that will only fire when the right person is using it. And none of those are available, and they probably never will be available in America anytime soon, because there are a couple of states, I think Rhode Island is one, that have passed trigger laws so that as soon as any gun is for sale, that it can only be fired by one person by doing something like reading your palm print, then all other gun sales would be illegal in that state. And because of that, the NRA and basically the Republican Party has very, very strongly blocked any effort to sell any commercial biometric guns in America. And so it's not illegal to make them, but it's politically suicide for any politician to allow it, so it's never happened yet in America. And then you've got police vehicles. They have cellular vehicle to everything is a standard, which is a way for vehicles to be connected to the internet and transmit data while they're driving around, have GPS and other network devices on the phone, on the police car. And cars are IoT devices now. Cars are all full of data, all kinds of gadgets in there. And the most obvious thing would be the infotainment system that also has a GPS record of what you've been doing and your phone calls and such. All right. And so one thing that is a very common situation then is you will go to, for the police anyway, you go to a crime scene and you'll get some gadgets, and you really don't have the technical capability to do a sophisticated analysis of those devices. So you can use low-tech solutions, like just photograph what you can see on the screen and such. And there's also dogs that can sniff up devices that have this electronic chemical in it, so they can tell where hidden electronics might be. All right. Well, that's it.